Hey everybody, this is a short clip video that's going to come in on a bigger lesson that covers distance from a point to a line. This specific example in this clip is going to deal with coming up with the distance from a point to a line segment. The numbers are going to get nice and ugly. It's very representative of what you could deal with. I hope it helps you out. Good luck. Well, now you take a look at problem 2, and you'll notice that point A lies between your endpoints. It is that perpendicular distance. We should be good to be able to solve this problem. So, what I would love you to do is to try to solve this one on your own now. You see a fully labeled diagram. Let's try to take that and work our way through all of those analytic geometry skills and see if we can come up with the distance from point A to BC. Okay, pause the video now, give it a shot. Okay, we are back. So, for us to go through and deal with this, we're going to have to find the coordinates of point D, which means we're going to have to solve a system. Unfortunately, we need to build 2 equations. So, my suggestion to you would be use little headings. What I'm going to do is, first off, I'm going to try to build the equation of BC. That's what I'm looking for. I know to build the equation of any line, I need point and slope. Well, I have point. I actually have 2 of them, both B and C. But I don't have the slope. However, I can calculate slope. So the first thing I'm going to do is I'm going to find the slope of BC. And this is going to be me dealing with rise over run. I notice that I went up 2 for a rise, and my run was 14. That's going to give me a slope of 1/7 when I reduce. And now I can take that slope and I can use one of my points and I can build the equation of BC. So I'm going to now take my slope, and I think I would use point C just because there's no negative coordinates. So when I sub that into my slope coordinate formula, I don't have to worry about making any silly sign mistakes. Okay, I can multiply that out. And now I can put that in standard form. Now, I don't know whether standard form is the best form of this equation for me, but I'm going to put it in standard form just until I can make a decision on that. Okay, I now have the equation of BC. Nice. I now need to build the equation of AD. So what I'm going to do is I'm going to build another little heading. I know that the slope of BC was 1/7. I calculated that. What I also know then is that the slope of AD is perpendicular. So I know that the slope of AD has to be the negative reciprocal of 1/7, or -7. I need slope and a point. I have the coordinates of point A, so I'm going to use my slope of -7 and my coordinate of point A, and I'm going to sub those into my slope coordinate formula. Well, now I can go ahead and I can put that in a useful form. And now I'm getting to a point where I'm going, okay, I'm going to have to solve a system. I could generically write this in standard form and say 7x plus y equals 16. But then I'll notice pretty quickly that's not going to be a nice system for me to solve. What I mean by that is if I want to use elimination, I'm going to have to multiply an equation by something. If I want to use substitution, I'm going to have to rearrange. So my suggestion to you would be, as you're starting to rearrange the equation now, when you're trying to make that decision, do I go standard form, do I go slope-intercept form, it might be useful for you to go through and change that and write it into slope-intercept form, because that way your y will be all by itself and you can now sub it into the other equation. Okay, there's my equation 1, there's my equation 2. I am now going to solve for d, or find d, by solving my system. Okay, I need to slide this up on my screen. So I am now going to find the location of d. And I'm going to do that by subbing equation 2 into equation 1. I have now isolated for my y. I can now sub what it is into my equation 1. Of course, had you taken equation 1 and isolated your x, you could have subbed that into equation 2. Either way is good. Okay, I now have my equation for x. Now it's just some algebraic work, making sure we're not making any silly mechanical mistakes. 7 times 16 is a 70 and a 42. So a 70 and a 42 is 116, yikes, 112. That gets me a 50x is equal to, now I need to take that off, and that's going to get me a 92. I can now reduce that fraction and get 46 over 25. A nice, neat x-coordinate. Ugh, that's ugly. Okay, I can now take my x value of 46 over 25 and sub it back in. Now, for some of us, because we got this value of 46 over 25, we might go, oh, that's ugly. I must have made a mistake. Don't let getting an ugly number make you feel like you made a mistake. Trust it. Not all your answers work out to nice, neat things. Look at your diagram. Look at your sketch. Is it reasonable that your x could be 46/25? Yeah, that's a high 1 point something. That's reasonable. Look at the location of D. So trust yourself. Now I'm going to go ahead and I'm going to plug that in. And I'm probably going to sub it back into 2 because the y is already isolated. Well, that's going to get me y equals -7 times 46 over 25. Oh, this is going to get ugly. Okay, I'm going to get something nice and big. So I'm going to go ahead and I'm going to calculate that 46. I would take a first look, though. My 7 does not reduce with that 25, and we should always be looking to reduce that thing. So since it doesn't, now I'm going to multiply my 7 in. That's going to get me a -322/25. And right now, I can see I'm going to need to get a common denominator. So why don't I already change 16 into 25ths? That's going to get me 425ths. I now have my common denominator, so I can go ahead and put those things together, and that's going to get me a value of 78/25. Now, my denominator is 25. It's only made up of 5s. I see that there are no 5s in 78, so therefore, I know that point D is fully reduced at 46/25, 78/25. Oh, this has not gotten any neater. So back on my diagram, I'm just going to label the coordinates of point D. I found that D was at 46/25 and 78/25. Now, I take a look at that solution. Again, don't doubt yourself, but check. So that would be a 1 point something and a 3 point something. And that makes sense. Look at the location. Because I was trying to be as accurate as I could be when I made my picture, that fits my diagram. That makes me super confident. Now, I just need to come up with the length of AD. So I am going to wrap back around. I'll shrink this down for 1 second, but I'm going to wrap back around And now I'm going to actually answer the question that was asked. I'm going to find the distance from A to D. So A to D is now big ugly square root of my right triangle. Well, my right triangle now gets pretty ugly. Okay, my vertical distance is going to have to be from 78/25 all the way down to -5, which means I need to take that distance of 78/25 and add on down to 5. And then my horizontal distance is going to be from 46/25 over to 3. So I need to find the difference of 3 to 46/25. Okay, a ton of common denominators, a ton of ugliness. Let me show you a little trick as you work your way through. Okay, first off, we're going to have to get common denominators on the inside of our brackets. Now, for me to calculate that, I want you to watch what I'm going to write down. I'm going to now change my 5 into 25ths, so that is 125 of them. And I'm going to do the same thing on the other, change my 3 into 25ths. There is me using my Pythagorean theorem. There is me getting common denominators. What I now need to do is simplify the tops of both of those fractions. So I am going to take my 78 and I'm going to add to that a 125. So that is going to get me 203 25ths. And then on my other fraction, I need to take a 75 and minus that 46. So there is a 29 25ths. Okay, we're still working on it. Yikes, this is ugly. I'm going to just slide that up to make a little bit more room. When I go to calculate that, I now need to square all parts of your fractions. Okay, you're going to watch the way I write this down. I can see that when I go through and I square the top and the bottom of both fractions, I'm going to have a common denominator of 25 squared. I'm not even going to calculate what 25 squared is. And you'll see why in a second. Okay, on top, I now need to square my 203. Well, that's going to give me a nice, big, nice, and neat 41,209. Yes, I'm using a calculator on this. That's not me pulling that out of my head. Now I need to square my 29, and that's going to get me an 841. Okay, keep following BEDMAS. If I take my 841 and now I add to that my 41,209, then that is going to give me a 42,050 over 25 squared. Okay, you may be asking, hey, why are you still not calculating 25 squared? Because look what my next operation is going to ask me to do. I'm either going to reduce that fraction on the inside, or I'm going to take the square root of 25 squared. Okay, I am running out of all sorts of room, so I am going to wrap all the way around here so I can continue my work. Well, I'm now going to calculate, or simplify, the square root of 42,050, because I can take the square root of 25 squared, and it's just a 25. That it wasn't worth it for me to ever calculate my 25 squared, write down 625 every time, and then keep going through just to now take the square root of 625 and get back to 20. Maybe you can see what I'm talking about in that orange. Okay, I would love it if when I took the square root of 42,050, I got a whole number, but I don't. So that means I am doing a nice big factor tree. I'm going to just shrink my marker a little bit because this could take a while. So what I'm looking for is perfect squares. Well, my answer ends in a 50. So I know then that 25 is going to go into that evenly, and 25 is a perfect square. So that's not a bad number to divide out from the very beginning. Well, now I've got my 1682. I notice that if I divide that by 4, I get a decimal. So the most I can divide in terms of that even number would be a 2, but at least that would allow me to shrink it down a little bit. That's going to get me 2 times 841. Well, hey, if I go back into my work, I notice that 841 is 29. So that is a 29 times a 29. And I've now figured out my factor tree to be able to reduce that to lowest terms. So maybe I'm going to just sneak in this line in here if it helps you a little bit. I can take the square root of my 25. That's a 5, so that's gone. I can take my square root of 841. That was a 29, so that's gone. The only thing I couldn't take the root of was the 2. It's left in there. However, I'm thinking that a lot of us would be okay just to go straight to my 5 times my 29, and that was a 145 root 2. But now you see with your whole numbers, you have a common factor of 5 in there. And so if you take your 145 and divide it by 5, you get back to your 29. And take your 25 and divide it by 5, you get back to 5. Holy cow. Okay, that was messy. But we finally answered the question. What is the distance from point A to that line segment? All the way at the end, it's 29 root 2 fifths is our distance. Okay, that was a huge problem for us. But again, look at all the parts in there. We should be comfortable to deal with all those parts. You had to go through and build some equations of lines. No problem. You had to solve a system. Shouldn't be a problem. You had to find the length of a line segment. Shouldn't be a problem. Even though the numbers got really ugly. Take your time, map out your process, have confidence in your skills. Okay, 2 problems for today with a little bit of a discussion on some theory about how we measure distances from points to lines. Your job, jump in and get as much practice as you can and make this process automatic. Good luck.